Algebra 2, multiplying and dividing radical expressions. Our objective on this video is going to hopefully be so that we will be able to apply exponent properties to simplify radical expressions when you have multiplication and division involved. I would just like to remind you of some terms that we will be using. The first one is called the radical, which is the symbol, and anything underneath it, the whole thing together, is called a radical. The part in the radical is called the radicand. And this is the root, and I'm calling it the nth root, and n could be any number. And this is the power. This is the radicand in this case is also a power because we have a variable to an nth power. And an nth root of an n power is just what is the base. The x is our base here. Or at least that is the case when it is an odd n. When you don't, and when you have an even n, we have a little bit of a different thing. So what I'd like to talk about first as we review this is when you use the absolute value. So let's give some examples here. The square root of 9, and we're really talking about principal square roots. So the principal square root of 9 is 3. So I know that it must be 3. The principal square root of 3 squared is also 3. But if I have negative 3 squared, I know that my square root is also, because negative 3 squared is 9, the square root of 9 is 3. Now if I have the cube root, remember that is something that's timed itself 3 times, of negative 8, that is negative 2. So notice, if I have a square root, I am never going to have, as long as a principal, we're talking a negative square root there. And I don't have a negative number in here either once I do the square of it. But if I have a cube root, it really doesn't matter, because I can when I multiply it 3 times, I will get a negative number, so that's okay. So because of that, when I go to doing square roots or even roots, I'm going to have a positive value out here, or a positive x. So when I take the square root of x squared, I have an even power here, an even root, because there's like a 2 here. It's going to be x, but my square root of x squared is x. However, since this is odd, I need to put the absolute value, because I know I need the positive value of x. Now if I have a cube root, and it won't matter so much. So my cube root is just b, because it doesn't matter. If b is negative, that's okay, because I have a cube root. It's an odd root. But here we go again. We have b to the 4th, and I have the square root of it. So b to the 4th, remember we kind of just divide. This is, pretend there's a 2 here. 4 divided by 2 is 2. I get b squared. Now, you would think I have to put an absolute value around this. However, since I have b squared, whenever any value squared is going to be positive, so I don't need it. So I only need the absolute value, and you might want to make note of this somewhere, is if you have an even root, like 2, or 4, or 6, or 8, of an even power, here's a 2, that results in an odd power. And this is the only one that did that. You have to include your absolute value. Even root, even power turns into an odd power. That is the only time you need the absolute value symbol. Okay. Now, just a review of multiply and radical expressions. If you have the same root, my n here, you can multiply them. So I have the nth root of a times the nth root of b equals the nth root of a times b. Now we can use this both ways. We can either go and put them together, or sometimes it helps me to take them apart. So let me show you an example of that real quickly. If I had the fourth root of 12 times the fourth root of 5, I can multiply that 12 times 5 and get 60, fourth root of 60. And that's good, and there's no actual fourth roots in there, factor, so that's what it is. Or I can go the other way. I have the third root of 250, and I can break that into the cube root of 125 times the cube root of 2, because 125 times 2 equals 250. And I know the cube root of 125 is 5. 5 times 5 times 5 equals 125. So I can go ahead and take the cube root of that, and then I leave the cube root of 2 just like that. And that's simplified. So here I've put them together using my multiplication, and I've also used that property to take them, to factor them apart. Similarly, I can also divide radical expressions. So if they have the same root, I can take them and divide them under one radical. So let me show you the example of this. So for example, I have the cube root of 56 over the cube root of 7. So I'm going to write that under 1, like this. Cube root of 56 over 7. And the cube root of 56 over 7, well, 56 divided by 7 is 8. So I'd have the cube root of 8. And 8 happens to be 2 cubed. 2 times 2 times 2 is 8. So I can just make that 2. So that shows you that it can help you simplify. So once again, though, I wanted to say that you can go from the two radicals and put them both under one, but you can also break it up. So let's use that for a couple more involved examples. So here's my examples. And let's just look at this one first. So the square root of 18 times x to the 5th over the square root of 2x to the 3rd. So knowing that they both are the square roots, so I can put them together. So I'm going to do that. So I have 18x to the 5th over 2x to the 3rd. Now I can simplify my radicand. 18 divided by 2 is 9. X to the 5th divided by x to the 3rd. When I'm dividing powers, I subtract the exponents. So 5 minus 3 is 2. And I'm taking the square root of all that. Well, the square root of 9 is 3. And the square root of x squared is x. But remember, I have an even root with an even power that the square root of it is odd. So I need to put the absolute value around that. So there's my answer. Let's look at the other one. I have the cube root this time of 162y to the 5th divided by the cube root of 3y squared. So once again, I'm going to put them under the same radical to see if I can simplify. So I have 162y to the 5th divided by 3y squared, all under the cube root. Okay, well, 3 goes into 162. How do I know that? Because if I add the digits of 162, I get 9. 1 plus 6 plus 2 equals 9. And 9 is divisible by 3. So I know that 162 is divisible by 3. So 3 goes into that, let's see, 54 times. 54 and 5y. Once again, I can use the subtraction or the division property of exponents. If I'm dividing powers, I subtract the exponents. I get y to the third. And I'm taking the cube root. And here's where I can say, okay, well, are there any perfect cube factors in 54? And remember, I should have my little chart. 1 cubed equals 1, 2 cubed equals 8, 3 cubed equals 27. Well, 27 times 2 equals 54. So I'm going to have 27 times 2, y to the third. So now I can take the cube root of the things, those are cube roots, of the things that I can take the cube root of. So cube root of 27 is 3, that comes out. The cube root of y to the third is y, but I can't do anything to the 2, so that has to stay in the radical. And that's my simplified version. I want to remind you that sometimes the simplified version does not look very simplified. Okay. So, with that in mind, this is a really good thing that you would probably want to jot down. What is a simplified radical expression?